Today we're going to talk about dividing when exponents are involved. So if you look at these problems, you can see that they are division. And remember that when we're talking about exponents, we have a base, and then we have the exponent that it's being raised to. So the base is x. The exponent is 6 in the numerator. The base is x in the denominator with an exponent of 2. So we're trying to make this a little bit cleaner. X to the 6th over x squared is the same thing as if we had 6 x's in the numerator over 2 x's in the denominator. And that's just the expanded version of it. And then when you look at this, you know that the same thing over itself, whether it's x over x or 7 over 7 or 2 million over 2 million, that's equal to 1. So this would be equal to 1 and these would be equal to 1. Therefore, the answer, the simplified version of this, would be x to the 4th. So when you have x to the 6th divided by or over x squared, you get x to the 4th. Here, notice that the base is actually a number, which is fine. Same thing applies. You have 4 5s on top and 3 on the bottom. And then we're looking for forms of 1. This is a form of 1. That's a form of 1. That's a form of 1. So my answer will be 5 to the 1st, or just 5 is fine. 5 is actually a little bit neater, but 5 to the 1st is equivalent to that. In our third example, similar situation. We have 3y's here. Down here we have 6. And we are looking for forms of 1. Form of 1, 1, 1. Whoa. That is weird. And then here we have 3y's, y to the 3rd left, but it's in the denominator now. And when nothing's in the numerator, because they were all 1s, we need to put a 1 in the numerator. We don't have to write a 1 in the denominator, but we do need to write it in the numerator. So y to the 3rd over y to the 6th is 1 over y cubed. Think about that. Why is that one in the denominator and these were not in the denominator? All right, and then here, similar situation. We have this time a base that's a coefficient, or a number, I should say. And then our base down here is also the 8. This is a form of 1. So you do have a 1 in the numerator because nothing else is in the numerator, and then 8 to the 4th in the denominator. So I hope that when you look at this, you realize that where you put the base is where there are more of them. So when there were 6 over 2, there were more x's in the numerator, so the x stayed on top. When it was 5 to the 4th over 5 to the 3rd, there were more 5's in the numerator, so it stayed on top. Here, there were more y's in the denominator, so it went on the bottom. Here, there were more 8's in the denominator, so it went on the bottom. And for these examples, the 8 and the 5 were not coefficients because they were being raised to a power. So make sure you leave the base where the exponent is higher. And then how am I getting the new exponent? I'm really subtracting, aren't I? 6 minus 3, that's why it's a 3. 5, now there's a 1 here, minus the 1, that's why it's a 4. 4 minus 3 is a 1, so it's an implied 1 here. And 6 minus 2 is a 4. I'm not really interested in you remembering rules, but understanding why it works,